All righty, we're rolling. So take it away,
Wonderful.
Gus. Thank you for joining this morning.
Not a problem. Hey, good morning, everybody. I'm going to go ahead and talk basics about the cloud. And I know that not everybody's exactly in the same spot. Some people are going to be very familiar with some terms. Some people are going to find some terms to be new. I want to talk a little bit about most of the things and the terminology that you're going to encounter in the cloud. It's going to take me about 20 minutes to go through the slide deck, maybe even a little less. And what I want to do is I want to have questions and answers afterwards of things that were not clear or things that I did not cover. So let's go ahead and start. The very first thing that what gave rise to the cloud basically is the fact that you can run a computer just like your laptop as a virtual system, as a virtual machine. Most people have their Checkpoint laptop. It has one CPU. The CPU probably has 2 or 4 cores. You have 8 gigs of memory. You have a hard drive. That's usually 1 terabit. But if you look at the servers today, for example, the Dell PowerEdge server, that has 4 CPUs with up to 28 cores each. So a single server box can have about 112 cores. It can have up to 6 terabytes of memory. It can have a gigantic amount of hard drive storage. So if we can run virtual versions of the laptop, how many virtual versions can we run on a rack-based server? We can actually run over 100, right? So it very quickly became not only feasible, but reasonable to say, instead of having one server dedicated to just one thing, let's cut it out and divvy out the little pieces to everybody. So as the mug and the t-shirt says, cloud is just somebody else's bigger computer up on the internet. That is pretty much the core of it. The capability for us to have a virtual version of a computer, a virtual version of a server, is what makes basically cloud possible in this case. If we looked at the data centers today, AWS has a data center that has an average of 80,000 of these Dell type servers, right? So what AWS engineers sort of started talking about themselves is like, look, we had all these servers. We're using a lot of that power, but we have a ton of that power unused. We can sort of rent out little pieces of those servers to other people. People found out that, of course, if you are using a virtual version of a computer instead of a real laptop or a real server, you have something that's cheaper to build because it's just an image of it. It's something cheaper to maintain. You need less technicians to take care of it. Nobody needs to go into a room and rack it and put cables into it because, again, it's not the real machine. It's not the real computer, but just a virtual image of it. And today, we have the capability of creating virtual images of pretty much anything that goes in a data center. We can create virtual servers. We can create virtual routers. We can create virtual load balancers. We can create virtual layer 3 old-style firewalls. We can create virtual versions of the Checkpoint firewalls. We can create virtual versions of VPNs, virtual hard disks. We can actually create entire virtual data centers with all these pieces and store them inside of the real physical data center. You can have the equivalent of a 61 or a 64K with 128 cores of power, and you can have multiple of those spread out virtually inside of a data center. So the idea that if you have a very large data center with spare capacity is available, you can now use that to basically create entire virtual data centers without you having to find a building, rack equipment, have people and personnel there to maintain everything. All you do is you connect and you basically rent a little bit of some other else's server. The big analogy that I used to use was hotels. Before hotels were invented, back in the 1600s, 1500s, if you lived in England and want to go to France, you had to know somebody in France that you could check up with, basically. You're going to have to go and visit a relative or something like that. When hotels came out, you did not need to build a summer home in a different country. You could rent a room in that hotel for a single hour, a single day, 2, 3 rooms, just the ones that you needed. They came with their own maid service, with their own chef, so forth and so on. Same thing in the cloud. Instead of having to pay for a data center, having to rack all the servers, paying for the people. You're just renting a little piece of a server in somebody else's data center, whether it's AWS's, Amazon's data center, Microsoft, so forth and so on. I'm going to go through some of the terms that you will hear when we're talking about a cloud, and I'm going to summarize them as well. When people talk about having a cloud, let's say in Amazon or in Microsoft now, they may be talking about availability zones in the cloud. That is just the same thing as data centers. If you drive down in Northern Virginia towards Ashburn, you're going to see buildings just one after another that look exactly the same. Basically, most of those are Amazon data centers. If you have multiple data centers within a few miles of each other, Amazon sort of groups them and calls them an availability zone. When somebody says, hey, you can store something on availability zone A or B or C, you're really just putting them in separate data centers that may be a few blocks down from each other. And the whole idea is if the stuff you have in a data center goes away because you lose the entire data center, you have a copy of it on another data center that is next door or nearby. So when you hear terms in the cloud referring to availability zones, basically that just means, A, it's either one data center from Amazon or Azure or another data center that's down the street. And it's basically used for redundancy. The fact that we can have all these virtual pieces and we have all these data centers, including fully redundant data centers, means that people can come in and build their own virtual data center. In here, we have, for example, somebody that may have built something in AWS. They have their virtual servers, which AWS calls instances, and we'll go a little bit more into that. They may have load balancers. They may have old-fashioned security groups. This is basically the equivalent of a 2002, 2003 firewall. They will have routers or direct connections. You have an actual network that's defined into the cloud. You have maybe a virtual hard drive where you can store stuff. But unlike a real physical data center, almost anybody that has access to the virtual account can make changes to it. This can be a contractor, which can be a genius, or somebody that's not as bright, or it can be somebody that is malicious, that's trying to do something. So it's really difficult to go into a real data center and break in and open a computer and put a network card in that computer and connect it to another internet network with anybody, without anybody noticing. But it's real easy to do in the cloud because everything in the cloud is virtual. And you can create servers anytime you want to. You can create load balancers anytime you want to. You can attach interfaces anytime you want to. And you can connect those interfaces into internet gateways anytime you want to. And that little bit of wild, wild west, where anybody in the cloud can be given access to creating servers, to creating hard drives, to creating links, is what makes it a little bit dangerous. You have the same thing in Azure. Basically, just like you can create things in AWS, you can create equivalents of them in Azure. The names are a little bit different, but it's basically the same thing. Instead of your virtual laptops or servers, instead of being called instances like they are in AWS, they're called virtual machines in Azure. You have load balancers as well. You have hard drive-like storages, which instead of S3s is called blobs. And again, I'm going to summarize these terms in a bit. You have the equivalent of the 2001, 2003 old-style layer 3 firewalls, which they call network security groups. You can define virtual servers, which are basically just called routing tables. You can have whole SQL databases that you can rent out. They call that the SQL DB service. They're called RDSs in AWS. But the bottom line, again, is anybody with a portal account or anybody with access to an Azure subscription could have the rights of creating these hard drives, creating these 2001 style firewalls, creating the virtual servers, creating VPN gateways and attaching them to the internet. So again, there's a little bit of that wild west access to it. Okay, So let's say we want to build our data center because it's cheaper. I don't have to go out. I don't have to rent a data center. I don't have to do a co-location. I don't have to rack servers or hire people. I'm just going to go into Microsoft or go into Amazon, and I'm going to build my own network. And of course, I want to do security. So I'm not only doing my servers, and I'm maybe using some of their 2001, 2003 old style firewalls. I have my load balancers. I have my internet access, but I want to use a next generation firewall like Check Point. So I put virtual versions of that generation firewall as well. And I'm piping all my traffic through those, but I have a contractor or somebody that may have misconfigured one of those old style firewalls and given themselves internet access. And suddenly I have traffic coming in through the back door, something that I'm not aware of. Like somebody in my team just opened a window and left it wide open so that they could come in, or it left the door in the back unlocked and nobody knew about it. When you have a big data center like this, and you have a lot of people that are doing changes, you don't always know what some people are doing just because they didn't know better, or because they wanted some convenience, or because they actually have some intent that is not 100% valid. So you may design your network beautifully, having and inspecting the traffic that's coming in exactly the way that you want to, but you can have somebody that went in and basically did something, added a network card, a virtual network card to one of your virtual servers, or gave themselves a public IP address, or basically open a window or a door right in the back that is not going through security. So one of the things that most people have found out is that about 80%, this is Gartner that are mentioning this, about 80% of the breakings, of the issues that happen with cloud today are not necessarily somebody attacking through the network, which of course also happens, but somebody that either maliciously or accidentally misconfigured something when they were creating the data center, or when they were expanding it or making changes to it. I'm going to go ahead and talk a little bit about, go back to the next slide. I want to go ahead and summarize some of the terms that I talked about, and you're going to hear them over and over again. And I just want you to have some sort of understanding of what they basically are. When you hear about compute power or compute service, what people are talking about is basically those virtual computers that you can create on a cloud data center. They can be very small computers. They can be very large servers. These are all created virtually, and they have different names. AWS calls them EC2 instances. EC2 is just an E with two C's for Elastic Computing Cloud. And Azure calls them virtual machines. Google also calls them virtual machines. But basically, it's the same thing that you can see in VMware or Hyper-V. It's basically just a fully virtual version of a computer.
Hey, Gus?
Yes. Go ahead.
We should just pause a minute and see if we have any questions, if people are getting the concept, so on and so forth.
Mm-hmm. Okay, yes, sure. Fine. I meant to do questions at the end, but we can do questions as we go.
I don't want to overload them. Maybe they didn't quite understand. And so I just want to have an opportunity to let them,
sure,
if there's any thoughts or questions.
Yes, by all means. So far from what I talked about data centers and using those data centers to build virtual versions of data centers for ourselves. Any questions so far?
I think what we'll do is we'll use the chat window if questions come up, and then Gus, we can let you know as you're presenting.
Perfect. Not a problem.
Okay.
Okay. So we talked about that we can create computers and servers virtually in the cloud. AWS calls them EC2s. Again, these are virtual servers. They can be running anything. A virtual server in the cloud can be running Check Point. It can be running a web application. It can be running a web server. It can be running a database. All these servers are called EC2s regardless. You get to decide where you're going to run Windows on it, where you're going to run a Check Point application on it. You decide what you run in it. The basic unit is still basically called an EC2 instance or a virtual machine. You can create these any size that you want. You can make them with 1 CPU and 2 gigs of memory. You can make them with 128 CPUs and terabytes of memory. That's the beauty of the virtual system. I talked that they have a built-in set of virtual firewalls. This is 2001, 2003 technology. And I'm going to give a quick example of this because I usually mention this on my presentations. You guys know that Check Point, of course, has been in firewall since the 90s. And the only year we did not get a leader designation quadrant in our ratings was 2003. Gartner did not have any leaders, not just Check Point. They didn't put any leaders in 2003. 2003 was the year of an attack called SQL Slammer. SQL Slammer was simply traffic that looked like SQL, looked like just regular SQL from databases, so most people would allow it on their networks, but it was actually malicious. It was an attack that was just pretending to be SQL. SQL Slammer went through layer 3 firewalls, which is what we had in 2003, like if they were not there, like butter. And Gartner said, if attacks are going to look like this from now on, all firewalls to be effective are going to have inspection at layer 7 because a layer 3 firewall by itself will not be able to stop these new attacks anymore. So in 2004, we introduced our application intelligence. And once again, we were a Gartner leader. But the bottom line is that all these built-in virtual firewalls that you can get in AWS and you can get in Azure are the old version, the pre-2003, that is completely oblivious to attacks like SQL Slammer or anything pretending to be real traffic. But you can use them, and they're still valid, and they still do access control, and they can still be left open and misconfigured. So that's a pretty good thing to remember. You can build complete networks. AWS calls their networks virtual private clouds, and for VPCs for short. When somebody's talking about VPCs in AWS, they're really just talking about their networks. When you build a network in AWS, you basically are building VPCs. AWS tells you, rightly so does Azure and Google, that you should break down, and instead of having one gigantic network for everything, you should have a bunch of smaller networks and segmenting things out. That is just zero trust. That segmentation is one of the basic security principles. So most networks will have a bunch of VPCs. Azure calls those networks virtual networks or VNets. And again, Azure recommends that you have a bunch of those. An account, we talked about people having credentials in order to create these networks and create computers and create load balancers and connect everything together. You need an account to do that. The accounts in Azure are called subscriptions, in Google are called projects, in AWS are called just regular accounts. We talk about availability zones. That's just data centers. So AWS will say, hey, you can create your network in availability zone A, and you can have a copy of your network for redundancy in availability zone B. Availability zone B is just another data center that's a few blocks down the road. Routing tables. Every single network in the cloud has a built-in router associated with it. And that router has routes. Microsoft has something awesome called user-defined routes, or UDRs, which means that you can basically create your own routes very specifically and force the traffic to go through them any which way that you want. AWS allows you to create routing tables, but does not allow you to route every single piece of traffic the way that you want to. They sort of take over from you on certain things. But the bottom line is the same. If you hear somebody talking about routing tables in the cloud, they're really just talking about the virtual routers that are built into the cloud. And again, every network and actually every subnet has a virtual router that's automatically associated with it. It's invisible. You really can't see it. There's no icon for it. There's no picture for it. But you can see the routing tables that belong to that piece. We talked about building things like gigantic hard drives in the cloud, or renting hard drive space in the cloud for us to store stuff. Those are normally called S3 in AWS. S3 is just 3 S's, simple storage service. But when you hear S3, you can just think of a really big bank of hard drives in AWS. that AWS is renting space to you. Kind of like again, we're talking hotel. You're not, again, buying an entire house. You're just renting a bed. Azure calls those storage pieces blob storage. Same thing again. Google calls them buckets. But the bottom line is when you hear things like S3 or you hear things like blobs, they're just hard drive space that you're renting out. There's a version in AWS for long-term called Glacier. Glacier is basically just a lower price bank of hard drives that you can rent. So instead of being SSD, very fast hard drive access, they may be all 54 physical platter disks, and it's basically just lower cost storage that you can use to keep things that you don't access frequently. You're going to hear about containers and Kubernetes. I'm going to talk a little bit more about that in some of the other slides, and that's something that's becoming more and more popular. Basically, Kubernetes is something that's used throughout, but you have a lot of third-party products that do container orchestration as well, and we're going to talk a few minutes about that. You're going to hear about serverless in the cloud. Things like Lambda, Azure Functions, which is basically what Lambda is. These are just macros. This is basically just programming languages, almost like shell scripts that you can run on Checkpoint servers. You can run scripts in the cloud on AWS's computers and in Azure computers. You don't have to make your own servers to run these things. You can just, hey, I need to run a little script that does this. Instead of putting up my own server and writing the script, I'm just going to run a script on one of AWS's computers.
Hey, Gus,
Yep.
we have a
Yes.
couple of questions that come up. I don't know if you see the chat window.
Yep. Tell me.
There's one from Brian Hepner. Is a typical availability zone? What does the physical geography look like?
Okay. Normally, it's about a couple of miles between availability zone data centers. And that is one of the reasons why when people ask, can you do a cluster between availability zones? The answer is no, because we would have one member in one data center and the other cluster member would be 2 miles down the road in another data center. And there's no way for us to keep state sync when the members are that far apart. So think at least 2 miles, 2 to 5 miles. The whole idea is if there's a fire or an explosion in one data center, the other data center is far enough to be safe, but it's still in the same region. It's still in the same Ashburn or the Virginia area or in the same Ohio data center system. So you're geographically not very far away, but just far away from the first data center that you have that full redundancy if you lose an entire data center.
Okay. And then the second question was by Bian. It says, how does AWS Transit Gateway Services change our methodology of transit VPC architecture?
Oh, okay. Well, that is definitely a little bit beyond 101.
Okay.
But I can talk about it real quick because it's not that bad.
Okay.
All a transit network is basically, let's say you have shared things that you want to use. You did good. You pay attention to Amazon and Microsoft, and you build a bunch of little networks instead of one big gigantic network. And one of those networks has things that you want everybody to use. Things like Active Directory authentication, things like a central storage. Maybe you have one big checkpoint gateway in there and you want all your traffic to go through that one checkpoint gateway instead of having a bunch of little checkpoints in every single network. What the transit network lets you do is basically join all your networks to that central network that has the information that you want. The reason we use the word transit to describe this, which is really just a hub and spoke configuration, is that AWS and to some extent Azure, but it's mainly the term transit comes from AWS. AWS does not want and does not normally let you have one network connected to that central network and then go through that central network to go to another network. Kind of like, let's say the kitchen is open to every room in the house. Okay, you can go from any bedroom into the kitchen, but I don't really want you going from your bedroom to somebody else's bedroom by going through the kitchen. That is not secure. So that's what's called a transitive kind capability, to be able to use a middle network to move from one network to another network, and AWS basically blocked that down. Now, some people want to do that. They say like, hey, every room in my house goes through the kitchen. I want to be able to have people use the kitchen as a communications to go from one side of the house to the other. And we do that using VPNs. By using VPNs, we hide the traffic from AWS. AWS doesn't know where that traffic is going, so it cannot enforce that prohibition. And we call those transit networks because they give us back that transitive quality through that center hub, ignoring the restrictions that AWS put in our system. The new transit gateway that AWS just released just basically allows you to do a bunch of, go beyond a bunch of the limits that the old ones had, makes configuration easier. You can scale up the amount of capacity that you have in your links. When you were hiding things in the transit network before, you could only go up to 1 gig. Now you can scale that up. Again, we can talk more about transit networks probably. I could probably talk about 4 hours just on transit networks and things that we can do.
I think that's good. Thank you, Gus.
Not a problem. We have multiple types of load balancers in the cloud. The regular load balancers are called elastic load balancers in AWS, just regular load balancers in Google load balancers in Azure, and Google load balancers in Google. But we have multiple types of load balancers. So you may hear things like application load balancer or network load balancer or standard load balancer or basic load balancer. Those are models. And each one of them does things a little bit different and has more options than the other ones. But basically, they do the exact same thing that any load balancer, whether it's from F5 or from A10 or from Alteon, the built-in load balancers in the cloud from AWS and Azure are basically the same thing. You want a little bit more options, you get a slightly different load balancer. You want to do just web, but terminate everything in a single IP, you might use an application one. You want to do all protocols and multiple IPs, you may do a network, but that's basically what that means. You can have caching engines in AWS, in Azure or Google that you can use to cache web data or application data. And each one of them has their name. You can have a full-blown relational database servers already configured and ready to go. AWS calls those RDSs. Azure calls SQL Database Service. Google calls them Google Cloud SQL. The whole idea is, hey, I could build a server. I could load Linux on the server. I could put a SQL database server on it. But I can also just rent a pre-configured database server from AWS or Azure and just start storing data into them. That's what these services are pretty much used for. You're gonna be hearing about orchestration tools, things like CloudFormation, things like Azure Templates, which is the name in Azure for the CloudFormation equivalents. All these are just scripting languages. They are just tools that let you define what you want in the cloud as code. And when you run them, it basically builds the stuff for you. Like my Ansible example where I just press the button and then it builds a bunch of networks and it puts automatically the checkpoint gateways and the subnets and it builds the VPNs. Since everything in the cloud is virtual, everything can be basically programmed to run off a script, which is one of the powers of cloud. You're going to hear the word tags a lot. Basically, tags are labels, which is why Google calls them labels as well, that we can attach to things that we built in the cloud so we remember what they are. We create a server in the cloud. We put a tag that says, this is a web server, or this is a web server, and another tag that says that belongs to Project X, or this is a checkpoint firewall. This is a checkpoint firewall that runs this particular item on it. So tags are little labels that we can add to the cloud objects that we create so we remember what they are, and we can group them later on, which is why it's very, very powerful that Checkpoint can create firewall rules based on tags, because we can now say, hey, everything that we created that we tagged as a database server, allow that to have the database SQL access to all these servers on this side that we tagged as application servers. And that way, by just adding a tag or removing a tag, we can make systems in the cloud participate in that security. I'm going to talk a little bit real quick about containers, and then we're going to go a little bit into some more of the discussions. But oops, I forgot about this slide. One of the things you're going to see about Dome9 is, unlike the CloudGuard gateways, which can see traffic, Dome9 is actually able to see all these virtual items that we create. It sees everything. It sees the instances, the RDSs. Again, that's the relational database services that are pre-configured for us. They see load balancers, all the types of load balancers. They see them in Azure. They see them in AWS. So, and we call those basically assets, all those things that form part of the cloud. I'm going to talk a tiny bit about containers, because you're going to hear about containers a lot, and then people are going to wonder whether we protect them or not. We know about VMs. We already talked about VMs. A VM is a virtual machine, where virtual machines have virtual CPUs, they have virtual network cards, they have virtual hard drives. They run virtual operating systems. So you can create a virtual machine that's running Linux or Windows, etc. Somebody said, hey, I don't want to build a machine, a virtual version of a machine, and load Windows on it and decide how big a hard drive should be or how many interfaces. I just want to run Microsoft Word. So companies, and Docker is a great example, came with the idea, hey, you don't need a whole virtual machine to do something. All you need is a little virtual bundle that has just the things that you need. It can be a specific application like Microsoft Word, or a web server application, or a database server, or a checkpoint firewall. But it's not running the entire machine, it's just running that one application and everything that supports that one application. So your VMs, your virtual versions of that are much smaller, because you're not building an entire machine, you're just building a little packet that has just the application that you need. So you could have a Microsoft Word container, an Excel container, a checkpoint firewall container, a web server container, and since they're a lot smaller, you can put a bunch of them inside of the virtual machines themselves. So if you have a virtual machine that's running Windows, you can put a bunch of smaller containers inside of that. Some of those may be running Microsoft Word, some of those may be running Excel, some of those may be running Outlook, but you can have a bunch of little processes inside of that VM, and they'll look the same. So you can grab the Microsoft Word container and put it inside of a different machine, virtual machine, that's running Mac OS or that's running Linux. It doesn't matter. If you have a version of that application that runs on that OS, basically the container would be the exact same thing, the same version of Word, the same supporting libraries. It's just running on other systems. Again, those little containers can be running on a Linux machine, and they can be running, again, web services. So if you remember our big Dell machine that can handle over 100 virtual laptops, each one of the laptops by turn can handle about 100 or more virtual containers of that little application. So now a single Dell server that could run 100 VMs can actually run thousands of containers. And basically that is why containers are so popular. It allows you, again, to multiply the power of your virtual network. Now, if you have hundreds or thousands of these little things running Word, you need something to basically orchestrate or help you define what's what, what's running, what crashed. I want to have 100 containers running Microsoft Word, so 100 people can log into those and do stuff. What happens if one of them crashes? I want something that is making sure that all my 100 Word things are working okay. If one of them goes to hell, it should basically destroy it and replace it. That is what a container orchestrator does. And the most famous today is called Kubernetes. Kubernetes is also called K8s. That is because you have a K, you have 8 characters in the middle, and you end with an S. It's no KAS, it's not scientific. It's just basically a short notation for Kubernetes. When you build a Kubernetes system, you're basically just explaining. It's almost like building a recipe. You're telling it what my container has. I want to build a container that has checkpoint running R80.10. and it's going to have firewall, and it's going to have IPS. But I want not just one of those, I want 10 of those. So Kubernetes grabs that and basically builds 10 checkpoint containers and makes sure that they're running R80.10 with the firewall and the IPS blade. And if any one of those 10 goes away, Kubernetes will see it and will bring it right back up to 10. We'll destroy the one that's not working and we'll add another one. That is the power of Kubernetes, and that's why it's so popular in the cloud. Again, if you hear words like Dockers and containers, are just little bundles that are virtual bundles that are running inside of our virtual servers, and allow us to run a bunch of little versions of web services or database services or things that we need of. And we can run thousands of these very, very easily. And that is basically what Netflix uses. When Netflix is sending you movies and you have 50,000 users that want to see the latest episode of Game of Thrones or a particular Oscar-winning movie, instead of basically trying to serve everybody from one gigantic server, it builds a bunch of little movie playing containers. And it basically goes from 50 to 1,000 to 50,000 of these little movie playing containers, and then scrolls right back down. That is the power of containers, and you need something like Kubernetes when you're dealing with thousands of these to keep everything straight. Okay, so some of the things that we have not yet talked about, but you're going to hear about. You're going to hear about IAM. IAM stars or means identity and access management. Basically, these are the accounts that control the authentication and access to your cloud. These are the accounts that you create that allow you to do everything or just one thing or just a few things. The top account in the cloud is called the root account. And if somebody, if a malware actor, if a hacker gets a hold of your root account, they can do anything that they want to your network. They can destroy it. They can duplicate it. They can make themselves 10,000 servers to run porn or to run cryptocurrency generation tools. So root accounts are the most valuable pieces that you have in cloud, and they have been stolen. Some companies have gone broke, basically had to declare bankruptcy because a hacker took control of the root account and pretty much told them, give me money or you're dead.
Hey, Gus, just a question on the container. There's a question that came and said, would each container be considered an asset?
No. And I was going to leave that to the Dome 9 presentation later on.
Okay, that's fine.
But yes, exactly. Dome 9 charges you for the virtual machines that you're protecting, but it ignores the little containers that may be running inside of those machines. So we don't care if you're running, 1 million containers inside of 10 servers, and 10 virtual servers. Dome 9 will charge you for the 10 virtual servers.
Great.
We talked a little bit about CloudFormation templates. CloudFormation, again, is just a set of tasks that describe our network as code. I normally do the example of the macros that people build with Excel. It takes quite a bit of time to do all the macros, but once you have everything built, you can just enter a number and everything recalculates down the line. Same thing, I can create a whole database, a whole data center in code and hit play, and it will just create it for me. The AWS built-in automation and orchestration tool is called CloudFormation. There are third-party companies that give free orchestrators. Terraform and Ansible and SaltStack are probably the most popular ones of those. But if you hear somebody talk about CloudFormation or Terraform or Ansible, they're just talking about scripts, about playbooks, about pieces of code that create networks and data centers and systems and servers in the cloud. Okay. I'm gonna talk about one other thing in here. I'm gonna talk about logs in the cloud. And I'm gonna talk about this because you're gonna see a little bit of this in Dome 9 later on. The cloud generates a lot of logs. We have hundreds of virtual servers. Those virtual servers can be running millions of containers. We have dozens, hundreds, or thousands of 2003 access control firewalls in there. We have checkpoint systems. All these things are generating logs. And all the logs get dumped in the cloud at one time or another, and you look at them, and they look like a bunch of numbers from the matrix. So one of the things that the Dome 9 is going to be able to do with the Magellan, and we'll go into that later on in more detail, is it helps you make sense out of these numbers. Not only does it know what all the numbers mean, it is able to visualize who is doing what and who's talking to what, and basically tell you without you having to figure out from that bunch of numbers on the screen, right? One of the things that will be possible eventually, and again, this is not a real screen. You cannot do this today, but this is what we're trying to do, basically. If you can create a visual representation of the network flow, and you wanted to say, I want to see all my web access into my cloud, you could see something like this. A bunch of systems out in the public networks are coming into your cloud on a bunch of, say, checkpoint gateways, and from there, they're flowing to the application servers up behind it. But what's this? On the same swim lane as the checkpoint systems, there's a little sucker right there that is going sort of sideways and not following the main flow. Finding this little guy in a page of code that looks like this is hard. But if you have a tool that basically tells you what the logs mean and gives you a visual representation of what's happening, this sticks out like a sore thumb very, very quickly. Hey, I got all my traffic going the right way. This is a malicious IP. It's hitting checkpoint. Checkpoint knows how to block it. But what the hell is this? Where did this come from? And being able to see who this is and drilling down into this person for more information is the power of visualizing logs. And you're going to see, again, I call this one CloudGuard and Dome9 integration, because it's basically a combination of some capabilities that Dome9 gives us and the capabilities that the checkpoint gateways give us. And hopefully we'll be seeing something like this pretty soon. Okay.
Hey, Gus,
yes.
will you back up one or two slides to the log a minute?
Yep. Okay,
just
sorry.
That we forgot to put this definition on there. But
Oops.
so these logs here, guys, are what gets sent to SIM. Okay, so they'll go these type of logs then get sent to Splunk or ArcSight or QRadar, and large organizations have millions of these a day, almost. Okay, that they accumulate. If they have a problem, then they have to go try to figure out what the problem is by looking through all these numbers, which is an enormous task. But that's important to realize that almost anybody you'll be talking to uses a SIM, and this is the type of information that gets sent to that SIM, whether it's a Splunk, ArcSight, whatever, QRadar. Okay, and then what Gus showed you, how we break it down and analyze it for them, there's tremendous value in the marketplace. But I realized we forgot to add SIM to the cloud thing, cloud definitions. Sorry.
No, I'm actually pretty much done and open to questions.
Yeah. So there was a question that said, "What is the segmentation from the DMZ?"
You mean on when we do the visual breakdown? This?
Yeah, I would assume so, since it came in while you were talking on the slide.
Okay, well, yes, these are the swim lanes that Dome9 gives you, and we will be going into a lot more detail on the Dome9 presentation as exactly what these swim lanes mean. But basically, we're just categorizing or grouping cloud assets based on how open to the world they are. So the external world would be on one side, the internal systems on the other. Things that are in between would be in between, and we have more than just these categories. But we're going to be using them in Dome9 a lot, so you can quickly know whether something is fully secure and only open to the inside, or whether something has an open window or an open back door and can have somebody coming in without you knowing.
So the obvious question coming in is, when is the Dome9 part of this need to block the portion so they don't look at the customer?
Yeah. I'm not sure I understood the question, but I think I did.
I'm reading.
The call will be next Friday, same time. We're going to send the invite out to everyone right after this.
Yes.
So this is part one. Part two will be, how do you apply everything we learned today to selling Dome9?
Okay, so any questions about the actual terminology about containers, about Kubernetes, about S3 storage buckets, about network security groups, or anything that we sort of talked about so far?
Just one question on this chart here. So all these different categories, some of them is terminology and so forth, but also are these services that customers pick when they're in engaging with these three?
Yes. Some of these are free. Some of these are for a charge. Like you can build this old layer 3 firewalls pretty much on anything. You can put them in front of subnets. You can put them in front of VM servers. You can put them on the entire VPCs, and they're free, which is why they're very popular and why people configure a lot of them. Things like UDRs, again, those are your specific route tables or your own router that you build in Azure that directs the traffic exactly where you want it, or route tables in AWS, again, those are free. The things that are pre-configured, the S3 storage or the blob storage in Azure, the SQL servers, the SQL database, RDS, those are pre-built services. Usually those will have an additional charge to them. Every single VM that you build in the cloud will have a charge, a compute charge associated with it. And also a charge if data goes into it and data moves out of it. The charge is just cents a minute, cents an hour. But eventually, of course, if you're talking about millions of servers, it sort of adds up.
Okay. All right. I think we get the gist of it. So just just to open it up to the team, was this helpful? Is there additional information you want to know that wasn't shared here? And just the Cloud 101, like we said, part 2 will be Dome 9. That will be coming up. Folks can go off of mute and speak up.
Hey, Bill, it's Mike. I'll jump in. Gus, awesome job as always. Thanks so much. I saw a chat from Kevin Clark, and I would sort of agree. I feel like we just scratched the surface. And I leave it with probably more questions and answers just because, I'm learning so much. So I definitely would like to understand if there's any type of training that we could take to learn about the cloud a little bit more. And then obviously interested in the next step, which is really understanding what we need to qualify an opportunity and figure out, how we position, Dome 9 particularly.
Of course, we can talk at length, and I'm pretty sure we will in the next Dome 9 on the presentation. But the nice thing is that everything in the cloud, because it's so flexible, it needs to be controlled and audited. So you need some sort of tool. You can do it manually, but if you have hundreds of mini firewalls, thousands of networks, millions of servers, if you only have 20, you're fine. The more of these you have, the more a tool like Dome 9 makes sense, because having a single person or even a team of people going through thousands of virtual machines or virtual firewalls or virtual networks to see whether they're configuring correctly is just impractical.
Yeah, don't forget that 98% of the things that happened last year, the threats that got exposed with the S3 buckets were just simple misconfigurations that, because they deploy so many of them, if you're just a human being, it's just going to happen. And with a tool like Dome 9, it can automatically be checked as it's being deployed that those configurations are correct. So that's what Gus means. If you have 10 of them, 10 S3 buckets, no issue. When you get thousands and hundreds of S3 buckets, it's a huge issue.
Hey, Glenn, this is Kevin. How you doing?
Good, Kevin.
My thing is, can we get either like on a day class or, is there a class we can go and sit down and with an instructor and spend a whole day or 2 days? There's so much in the cloud, and all my customers, are either thinking about it, moving to it, have strategic initiatives. And I think the more that we understand what they're going through and what's involved in this, in the cloud, and understand it and can be more of a resource for them, obviously we're going to leverage more sales.
Yeah, of course. And I think it's a great idea. I was just, as we're all mentioning this, what I'm going to do is I'm going to create a kind of a resource page. We'll post all this information. The recording will be there. And then next week's Dome 9, but also kind of like a blog. I'd like everyone to, submit questions, post, anything they'd like to learn to, that way we can hold those, day sessions like you mentioned. And what we can do is either have it, on site in person, team levels, or we can do region wide, and we'll just continue this. So if we get, a lot of people interested in, say, the cloud formation part of it, the scripting part, we can actually drill into that a little deeper, or whatever topic, but I'd like for, the team to drive that. So I'll certainly welcome all questions and suggestions for training topics.
And just to add something, Glenn, this is Yoni Leibowitz. We will reach out to you, and we are going to offer in the region, for at least for the SEs, a 2-day deep dive in the next month or 6 weeks. It's now being finalized, the details of it. The first one in New York is going to be held next week, and we are going to bring this training to every region in the next few weeks. So stay tuned, and there will be official Dome 9, hands-on, lab included training coming your way. So.
And salespeople too, please. Territory channels, so we can be the front lines in promoting. We need an understanding as well. And then I have a question going back to CPX. When the Microsoft CISO presented, he sounded like Microsoft Azure Secure. So where are we getting a little bit of a disconnect? And maybe this is for another conversation, but I just wanted to throw it out there.
Hey, I can address that really quickly because we really don't have a lot of time. But when he talks about Azure being secure, he's talking about this data center, these servers being secure, and they do have great protection against the denial of service attacks, against people coming in, against somebody that's in this server crossing over to something else that's in this server. However, when you create your own virtual data center in the cloud, you are the one that are building this. You can leave this stuff wide open to the world. And that's why we talked about share responsibility. Microsoft is in charge of securing this and this. When you build something in the cloud, you are the one that are creating these servers and creating this firewalls and these routers. So if you leave this wide open and you put some stuff in here, people can come in and through the internet and just grab it all. So securing this piece is what you're in charge of. And you do it, of course, with the CloudGuard and with Dome 9. Go ahead. Sorry.
That's true, Gus. But I think it's important to note that Microsoft Security Center, they're trying to pass it off as having some of the same capabilities as they add to it that a Dome 9 or a RedLock would have. So we're developing at Checkpoint Dome 9 a competitive sheet, or for lack of a better term, that's going to show what Security Center, Microsoft Security Center contains, and what Dome 9 adds to it for a much higher level of security. So that
awesome. Thank you.
That's key. I think that'd be very, very critical, because I think that's most of the objections that we get from Microsoft customers. Right?
Exactly right. And you'll start getting it from AWS, because they're building out their security center a lot more also. So
okay. Yep. All right. We probably should talk more about that offline too, Steve, with the team, and then we'll make a determination. Gus, thank you. This was extremely helpful, and well done.